Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on 11.1 worksheet, translation of parabolas. All right, so it says sketch the graph of each function. You must include 5 points, vertex, and 2 points on both the left and the right sides of the vertex. So first thing we're going to do on all of these is find the vertex. So from your notes, these here are going to be shifts. And remember, this is very similar to what we did with absolute value graphs. So this -1 means that we're going to go down 1, and this -2 here means we're actually going to go to the right 2. Okay, we always take the opposite of the sign. The better way really to do it is to say, what do I plug in for x so that this equals 0? Positive 2 minus 2 gives you 0, and that would be positive would be to the right 2. So what I'm going to do first is I'm actually going to sketch the graph of the regular x squared on here just so we have something to compare it to. Okay, here's the regular y equals x squared, just our regular old parabola. And that parabola, by the way, is the name of the shape that a quadratic, a x squared graph makes. Okay, so this is what we start with, and then now we're going to think of these as shifts. So we're actually going to take all these points and we're going to shift them to the right 2 and down 1. So we go to the right 2, down 1. This is actually now our vertex right here. Okay. Now, we can take all these points and shift them down 1 to the right 2, except for then you're going to have to graph all these things over and over again. There's another way that we like to do this, and I like to do our second set of points here, one to the right and one to the left, by using what I put in air quotes as the slope. This is x minus 2 squared. There's nothing in front, so that means there's a 1. So the slope to get to just the next points, not any points after that, but just to the next point, we're going to go up 1, since it's positive, up 1, over 1. So from here, up 1, over 1, that's going to be one of the points. And then we're also going to mirror image that the other way. We're going to go up 1 to the left 1. So just like what we have here, we went up 1 over 1, up 1 over 1 the other way. So up 1 over 1, up 1 over 1. Okay, now to get these other points here, we want to find the point that's at 4, because our vertex is at 2 and we found 3, and we found 1 point right on either side, so 3 and 1. So now we want to go one more out. So we went from 2 to 3, now to 4, and we went from 2 to 1. Now we also want to find 0. Okay. Now this is coming up in something that we're going to learn in a few sections from now, but I'm just going to show it to you right now really quick because it's a good spot for it. There's a line that goes right down the middle of, like a vertical line that goes through the vertex. That's called the Axis of Symmetry. Okay, and what that does basically is it's going to, like, all these points are going to reflect straight over this line. So like, think of this as a piece of paper and you fold it right down this line, this 3 is going to fold right onto the 1. Okay, just like here's the axis of symmetry for this black graph right here, the original y equals x squared. Fold it in half, that folds right onto this. If you fold this in half, this will fold right onto that point as well. So my point to that is, once we find either the 0 or the 4, the other one is going to just be the exact same on the other side, reflected over this line here. So really the question to ask is, do you want to plug in 0 or do you want to plug in 4? So I'm going to plug in 0 because that looks a little nicer. So we got y equals 0 minus 2 squared minus 1. So that's -2 squared minus 1. -2 squared is 4. Minus 1 gives us that y is 3. So we now know if we plug in 0 for x, 3 comes out for our y. So that's going to be another point that is going to be on this new blue graph. We're going to be at 0, 1, 2, 3. So there's another point. So this half of the graph is going to look like that. And then this half of the graph, we can actually, let's do this. Let's actually plug in 4 on this one just so you can see what it looks like. So we're going to plug in 4 to see what we get. Y equals 4 minus 2 squared minus 1. So that's going to be 2 squared minus 1. 2 squared is 4. Minus 1 gives us 3. So if you'll notice, look, we got y equals 3 here, y equals 3 there. So our other point is going to be at 4, 3. So we go over to 4, we go up to 3, and there's our other point. Okay. Now what I was getting at earlier, so the blue graph here is what we're looking for. The black one was just there for reference. You don't have to draw that, but the blue graph is what we're looking for. But what I was getting at earlier is once we find this point here, we can reflect it across this axis of symmetry line. So this is a distance of 1, 2. So if I just start here and I go over to the right 2 more, 1, 2, that's where this 4, 3 point is going to come in. Okay? All right, number 3. This plus 4 here says that we're going to shift this thing up 4, and then 1 minus 1 is going to give us 0, so that means to the right 1 and up 4. Okay, so we're going to go to the right 1 and up 4. There's our vertex. Okay, now to find the next points, what number is out front here? If there is no number, that means it's 1. So from here we go up 1 over 1. And again, if you imagine you have this little dotted line right here, you can reflect that straight across. That's a distance of 1, so it's going to be a distance of 1 over here too. Up 1 over 1 to the right, up 1 over 1 to the left. Okay. Now we also want to find 1 on this line here, which is at 3. And we also want to find the next one over here, which is at -1. So we can choose which one we want to plug in, and then we just mirror image the other spot over there. So I'm going to just choose to plug in 3 because it's positive. So let's try that. Y equals, you'll get the same answer for both of these, so it doesn't matter which one you plug in. 3 minus 1 squared plus 4. So we get y equals 2 squared plus 4. So we get 4 plus 4, which gives us 8. So that means another point we're going to get is at 3, 8. So we go over to 3, go up to 8. There's another point. Instead of plugging in -1, I know that it's going to just, if I fold this graph in half, this is going to go over, it's 2 units from this axis of symmetry, so it's going to be 2 units over to the left of that one as well. And then this is what our graph is going to look like. Okay. Okay. Next couple, number 5. This -1 means go down 1, and a -4 plus 4 gives us 0. So that means we're going to go to the left 4. Okay. So our axis of symmetry our vertex for regular y equals x squared is always here at the origin, right there at the middle. Origin is where the x and the y axis meet. And what we're going to do is we're going to go down 1 and to the left 4. So down 1, left 4, there's our vertex. Okay. Now, again, there's no number in front, so we're going to put 1 over 1. So from here, we're going to go up 1 over 1. You got to be paying attention to your scales on here. You can't always just go up to the next intersection and over. These are up by halves, so then we got to go up 1 here, over 1 there. We've got 3 points. We need 5 total. So I'm going to need to either, the next number over is -2 or -6. So I want to plug one of those 2 in. I'm going to plug in -2 because it looks a little smaller. So we get y equals -2 plus 4 squared minus 1. So we get y equals -2 plus 4 is 2 squared minus 1. We get y equals 4 minus 1. Y is 3. So -2, 3 is another point that's on this graph. So -2, 1, 2, 3. There's a point right there. Our axis of symmetry is that one right there. This is the distance of 1, 2 this way, so it's going to be 1, 2 more over that way, which is at the -6, and then we can sketch our graph. Okay, and you really, when you're sketching these parabolas, try to do a better job than I do, but always put arrows on the top, because that means that this graph keeps going up forever and ever and ever. Okay. Okay. Number 7, this +1 means it's going to shift up 1, and -1 plus 1 gives us 0, so that means it's going to go to the left 1. So axis, the vertex is here, so we're going to go up 1 to the left 1. Here's our new vertex. No number in front, so we put a 1 there. To get to the next point, we go up 1 over 1, and then up 1 over 1 the other way. And then we either want to plug in, we want to find the points here at 1 and -3. I'm going to plug in 1 because that just looks like it's going to be nicer to deal with. Y equals 1 plus 1 squared plus 1. And so we get y equals 2 squared plus 1. Okay, so we get y equals 4 plus 1. So our y is 5 in this case. So if we plug in 1, we get 5 back out. So there's another point at 1 and 5. Axis of symmetry is this line right here. Goes right through, vertical line right through the vertex. This is a distance of 2, so we go 2 more the other way. And there's our other 5th point. Okay, sketch a graph. That's pretty bad. That's a little better, although it's really more rounded. Should be more like that. This tablet thing that I draw with is really hard to draw decent curved lines. But anyway, excuses, Mr. Stansbury, excuses. Okay, so that's 5 and 7. We've got one last set here, 9 through 15, the odds here. Write the equation of the quadratic function with the following shifts. So they're going to give us the shift. We just have to come up with the equation. So if we go back and look at these here, these are our shifts, right? The one in the parentheses shifts it left and right, and the one outside the parentheses shifts it up and down. So if we do go back to this here, we know it's always going to be y equals, and we're going to have an x here. That's squared. It's always going to be plus or minus something over here, right? So the up 3, that means plus 3, and that goes always on the outside. The vertical shift is always outside the parentheses. And then left 6 means that this thing has to go to the left 6. So really this left 6 is -6, and that's what the x is. So I say -6 plus 6 gives us 0. So that's our equation. Y equals x plus 6 squared plus 3. Okay. On 11, we have just up 7. So we got y equals, I'm always going to start these off by just doing this. I know it's going to be y equals parentheses x squared here. So the up 7 means we're going to go plus 7, and that's going to be on the outside here, right? Plus 7. Now there's no horizontal shift at all. So really this is our equation. We can just leave it like this. To make it look a little prettier, we can rewrite it as, since we didn't put it into the parentheses, we can just write this as x squared plus 7. So we can write it either way. This is fine. This just looks a little nicer. Okay. 13, y equals parentheses x squared, something else out there. Up 8 means plus 8, and that's going to go right here, right? And then left 3 is negative. That means that this here is a -3. -3 plus 3 gives us 0. So here's our equation. Okay. And then last one here. Let's see. Down 6 means -6, and that's going to go out here, right? -6, that's a vertical shift up and down. And if you have a hard time, someone was earlier in class was saying I have a hard time remembering between vertical and horizontal. Vertical, think of like if you're jumping, if you are just standing there and then you're going to go jump, you're going to jump up. That tests your vertical leaping ability. And then also another way to look at that is there's also if you look out in front of you, if you're outside and looking out like into a pasture or something like that. Oops, I gotta plug in here. Sorry. There we go. I got that plugged in. Sorry. If you're looking out, there's a flat line out in front of you, and that's the horizon line, and that's horizontal. So vertical is always up and down. Horizontal is always left and right. Back to this one here. We've got down 6, and then, sorry, we're going to the right 3. So that means plus 3 is what this x value is. So I have to say 3 minus 3 is going to give us 0. So there's our equation. Okay? Okay, that's all we have for the 11.1 worksheet. If you have any further questions, please feel free to ask. Thanks.